Okay, we get to add on to what we did last lesson. 104 is called abstract rational equations. So it's very much the same as the lesson prior. However, you're going to have more variables. And that's okay. If you know the principles of algebra, you shouldn't have a problem. You realize that your answers are going to be very funky with lots of letters, right? All right, so here's an example. You've got 1 over x plus b over m equals c. Ugh. All right, and what they do is they tell you find m. And don't just circle it and say, here it is. That's a joke, okay? Kind of funny, but. All right, you're going to solve for m. You're going to isolate m, get it all by itself, all right? So just like last lesson, we want to clear the denominator, right? So this c, I'm going to put it over 1 so that everything is a fraction. So I want to, first of all, clear that denominator by multiplying through by the least common multiple of all my denominators. So in this case, my least common multiple is xm, correct? All right, so, oh, and let me caution that they also will always put this in the problem. That's letting you know that going into it, these are not worth 0, okay? Because that would be undefined. All right, so let's get this out of the way, and we're finding m, okay? So we're going to multiply through by xm, whatever our least common multiple is. So xm times 1 over x, the x's would cancel, and I would be left with m, correct? All right, when I multiply xm times b over m, the m's would cancel, and I'd have xb, right? The m's would cancel, xb or bx, doesn't matter. Okay, and then xm times c over 1, nothing would cancel out, so cxm. All right, so make sure you understand this step. Okay, I have cleared the denominator by multiplying through by the least common multiple. Now what you're going to do, gang, is look for anything that has m's. You want the m's all together. So I see an m here, and I see an m here. So I want them together. I'm going to subtract this, move it to this side, okay? So xb, or bx, I'll call it bx, doesn't matter, is cxm minus m. So all I have done is subtracted m. And I switched the order here because I like to go alphabetically. Now, do you guys see there's an m in 2 terms? So I need to factor that out, don't I? All right, so bx equals m cx minus 1. Right? If I factored an m out of here, the m's would cancel, leave me cx. If I factor an m out of m, I get 1. That's a minus. So again, make sure you understand from here to here. Now, I have m times something. I want m by itself. So I need to divide by that binomial to get m by itself. Well, if I do something to one side, got to do it to the other, right? So, what is m then? It's bx over cx minus 1. Now, I just think this is wonderfully fun. I hope you do too. So, I'm going to do another example. If you need to go back through this one, you might want to rewind and do it again. This is really easy, but it's so foreign to our minds with all the variables that sometimes it is a little confusing. But maybe rewind and do it again. Read the example in the book. Make sure that you understand. Okay? All right, so let's look at the next example. So this one is a over b plus c over d equals x. Now I'm going to make that x over 1 so that everything is a fraction. And as you see in the second example, they put to the side that b and d are not equal to 0. So what am I solving for? I'm solving for b. It always tells you at the beginning, find whatever letter. That means get that by itself, everything else on the other side. So first of all, with rationals, I want to clear the denominator. So I'm going to multiply the entire problem through by BD. So in the first term, b over b cancels, right? And d times a, ad. Remember, I'm putting them in alphabetical order. All right? In the next term, I'm multiplying bd times c over d, so the d's cancel, right? And it would be plus bc equals bd times x, and nothing cancels because it's over 1. All right, so again, stop, rewind, do it again if this didn't make sense to you. Now I'm looking for b. So I want anything that has a b to be together, okay? That's not for you, okay? So stay put. All right, so this is a b. I'm going to move it over. Okay, so it's eliminated on this side. I have AD equals b dx minus bc. Okay, b dx, take away bc. There's a b in 2 terms, so I need to factor it out, okay? So AD equals my b. I'm going to factor it out of the first term. It gives me dx minus c. Again, if I took a b out of these 3 things, I would get dx left. If I take a b out of here, I'm left with c. All right, so b times something equals AD. I want b by itself. So I'm going to divide by the binomial. Have to do the same thing over here. And so b is equal to AD over dx minus c. Now also I want to caution you, don't try to cancel parts of sums and differences. Remember, that's a very bad math violation. Straight to math jail doing something so evil. So don't do that. Don't say, oh, there's a d and a d. No, this is part of a product and then a difference. You can't do that. The only times you can cancel, folks, is say that you have, something like this, where it's a product. Then you could cancel your x's. But you can't cancel parts of a sum and difference, so don't do that. All right. I believe there's another one to go over. So let's do that. This is example 3. We have a over b minus c, and I'm going to write that as c over 1 equals d over x. Okay, this is example 3. It tells you that b and x are not equal to 0. Okay, so I'm going to clear that denominator. I'm going to multiply through by the LCM. In this case, it is bx. All right, so the b over b cancel. I have ax. Bx times c, nothing cancels, so bcx. And then bx times d over x, the x's would cancel, and I have bd. All right, so I cleared the denominator. Now I also need to know what I'm looking for. So for this example, I'm supposed to look for x, okay? Oh, so my x's are together. Good, I didn't have to do any adding and subtracting this time. So I do need to factor it out, though. And here's a place, too, where I really suggest you don't skip steps. Show everything, okay? Lots of places to make little mistakes. So if you show your work, and you check it when it's maybe not correct, then you go, oh, here's where I made my mistake. All right, so now we have x times a binomial equals bd, so I'm going to divide by that binomial. So I have to do that on both sides. And I have my final answer. Yay. And again, don't you dare try to cancel parts of sums and differences. Okay, you're already in house arrest. You don't want to go to math jail. It's even worse. All right. I believe there's one more example. I'm going to do this last one. I hope you see that anytime it's a single expression, I put it over 1 so that I'm seeing that I am working with fractions all the way through. Okay, so I'm going to multiply this all the way through by xn. That's my least common multiple of all the denominators. And again, this one I'm looking for x. Or I'm fine, I'm going to make that all by itself. Okay, so first term, xn times a over x. The x's cancel, and I would have an. Over here, I'm going to have minus xyn, correct? Plus, the n's would cancel, so I'll have an mx. Hope you see that. And then equals xnk. All right? Now, I'm looking for x. So anything that has an x needs to be all on the same side. So here's an x, here's an x, here's an x. So I need to add xyn to both sides. Cancels out here. I need to subtract mx from both sides. Cancels out here. And now I have everything that has an x on this side. All right, so I have an equals xnk plus xyn minus mx. Now, none of these are like. Remember, they have to be exactly the same. But they all have an x that could be factored out. So I'm going to do that. And when I do, I'm left with nk plus ny or yn minus m. So x is by itself. I'm going to divide by this big, long trinomial. It's okay, I can do that. Still 1, right? Anything over itself is 1. But if I do that, I do have to divide it over here. So some of these answers are going to be pretty obnoxious. So x is equal to an over nk plus ny minus m. You're done. All right, so go try A and B. Okay, so I multiplied the first one through by MB. My M's canceled. I have 3BZ. Here my B's canceled. I have MN. And nothing canceled here, so FMB. I'm solving for B, so I want to move this to the other side. I subtracted it. Then I want to factor the B out and then divide by that binomial. So B is equal to Mn over Fm minus 3Z. And we'll do B. Use the pen. All right, so I had to make everything over 1. I am looking for M, so I'm first going to multiply through by the LCM. The Y's will cancel. Nothing will cancel. The M's will cancel. And nothing will cancel. Okay, I'm looking for M. Anything that has an M needs to come over to the other side. As you see, I subtracted 3am. I added YMS. I am factoring out what I want to solve for. Oh. I thought I was solving for x. I'm solving for m. Okay? And then divide by everything that is not what you want. And do that to both sides. And there you have it. Alrighty. So refer to RenWeb for your assignment. God bless you. Hang in there. One day this will be over and we'll laugh about it. All right. Love ya.